Hello everyone. How are you all, dear students? And how about your studies going on? Do let me know in the chat box. So, guys, once again, a very warm welcome to your very own channel. Let's crack NEET UG in English. Myself, Sharada Alok. I have been teaching chemistry at Resonance from past 10 years. So, guys, how you can get connected to us? Let me answer this question to you. First of all, go to Play Store, then download the Unacademy Learning app, and then just click on to NEET UG. Done? And then go ahead for the subscription. Guys, you'll be finding two type of subscription are there. One is plus subscription and the other one is iconic subscription. Okay guys, so let me tell you the specification of plus subscription as well as the iconic one, and later on you all have to decide it yourself whether you go just want to go for this plus subscription or the iconic one. Let me tell you guys. First of all, guys, you'll be getting daily live classes. We are discussing about plus subscription, guys. You'll be getting daily live classes where you are going to be taught by the top educators across the nation. You can chat with your educator, you can get engaged in discussion related to the topic being taught on the screen along with the doubt you have. Yes, you can ask all your doubts and answer in the poll. These polls are going to have questions related to the topic being taught on the screen all while the class is going on. You can get that, and not only that, along with this you'll get your rank, your performance analysis, like how much time you have taken to answer that particular question in the form of being asked in the form of poll, and whether you have answered it correctly or not. Everything is going to be yes there in the form of leaderboard on the screen. Okay, guys, along with that, you'll be getting live tests and quizzes. Guys, these tests and quizzes are going to evaluate your preparation. Yes, going to happen on a regular basis, guys, and you are going to get a detailed analysis of your performance as well. Guys, there are so many benefits of the quiz. Let me tell you, the first benefit is no doubt it is going to add a lot to your academics. It is going to sharpen your negative marking. I mean, sharpen your IQ and reduce your negative marking as well. How come it is going to happen? Suppose, because how it is going to sharpen your IQ, let me tell you. First of all, guys, first of all, there is a time limit to answer the particular question in the quiz. You have to answer correctly to the question in a limited time period. Okay. And soon after the question gets over, that particular question is explained by the educator on the screen. So, no doubt it is going to add your academics. How come? It is going to tell you about that particular topic to which the question is related, isn't it? And the same question is going to be asked. Suppose if the same question or type of question or question related to that particular topic, which is already covered by the educator on the screen, will be asked again, what is going to happen? You are going to attempt that question correctly. This is how it is going to minimize the negative marking. And when that same question will be asked, or when that same topic is going to be asked again and again, your IQ is going to get sharpened, because you will start thinking into that topic again and again. Yes, guys. This you are going to understand only when you are going to feel it, when you are going to participate in it. Okay. Along with that, you'll be getting structured courses, guys. All our courses are structured very much in line with your exam syllabus, which is definitely going to help you best prepare for it. So just by taking one subscription, you get access to all our live and recorded courses, which you can watch from the comfort of any of your devices. This is another subscription, iconic subscription, guys, which is definitely going to take your NEET UG preparation to the next level with a personal coach, guys. The top educators, yes, you heard me correct. The top educators across the nation are going to be your personal coach. You're going to get a one on one guidance from the top exam expert as your personal coach, which is going to help you align your preparation strategy. Along with that, you'll be getting an in depth test analysis with personalized feedback. Definitely going to improve your time management and exam approach. Along with that, guys, you'll be getting a proper study planner, looking all your targets in to mind by, it is all designed by the top educators across the nation, guys, and definitely going to ace your preparation with customized study plan, looking all your targets into mind. Along with that, you'll be getting a bi-weekly review that is definitely going to highlight your progress, guys. So all by having one iconic subscription, you get live classes from top educator, mock test and quizzes, structured batch courses, very much in line with the exam syllabus. Let me tell you whether to go for plus subscription or the iconic one. See, decision will be yours. I'm just letting you compare for yourself, guys. Whatever you are going to get under plus subscription, whether to you are going to get under iconic one, guys, under iconic one as well. But as iconic name is added to this, it is having some iconic features in the form of personal code, study planner, expert guidelines, and in-depth test analysis. Now which one you are going to select, it all depends on you. Let me tell you how much you have to pay if you want to go for iconic subscription, guys. For 6 months you'll have to pay 38,000. For 11, if like for 1 year you'll have to pay 65,000. For 2 years you'll have to pay 1 lakh. But if you apply this referral code of mine, guys, you will have to pay only for like 6 months you have to pay only 34,200. For 1 year you'll have to pay 58,500. For 2 years you'll have to pay 90,000. I'm repeating, for 2 years you'll have to pay 90,000 by applying my referral code. Don't forget to apply this referral code of mine, guys. And one more thing, all the 6 month, 12 months, and 24 month subscription are available at no cost EMI. One more thing, guys, once you apply my referral code, no doubt you are going to get this discount prices on applying any other faculties, any other educators referral code as well. But if you apply my referral code, you are going to get some additional benefit, which you'll come to know once you apply the referral code and take the subscription. Now, guys, this is all about like how much you have to cost, like how much you have to pay for plus subscription. Let me tell you. And again, guys, yes, right, you can see on the screen, right, from 1 month to 2 years subscription are there on the screen. So like variety of the subscription are available over here. So for 1 month you have to pay 7,000. For 3 months it comes around 17,500. For 6 months you'll have to pay 28,000. For 1 year you'll have to pay 38,500. For 2 years you'll have to pay 56,000. Again, if you apply my referral code SA10, guys, you have to pay only 6,600 300 for 1 month, 15,750 for 3 months, 25,200 for 6 months, 34,650 for 1 year, 50,400 for 2 years, guys. This cost you around 2,100 per month. Yes, you heard me right. It costs you around 2,100 per month. One more thing, guys, you're going to get this discount prices by applying this referral code of mine or of any other educator. But trust me, if you apply my referral code, you are going to get some additional additional iconic benefit from my side, guys. Okay, and I just want to tell you that if you just want to go for 6 months, 12 months, or 24 months subscription, it is available at no cost EMI as well. Now, guys, now let us start for which you all are waiting for. Yes, you all are waiting to discuss questions of coordination compound. Today we'll be covering NCERT questions of coordination compound. Soon I'm going to bring many more video of this. Don't worry. Yes, guys. So today we'll be discussing or kind of bonding, what type of bonding, what type of ligands are there, what type of why complex compounds are different than double salts. Everything we are going to cover today. Don't worry. By the time, just take a pause and take a few seconds to share the link of the video to all your friends who are not only preparing for NEET 2021, 2022, but also preparing for JEE Mains, Advanced, or Class 12, or board examination, or planning for some improvement, or preparing for planning and preparing. Yes, KVPY. KVPY. Yes, guys. Okay, do share the link to all of them, guys. So what do you mean by coordination compound? Let us have a look here. Basically, we call them as complexes. What do we call them? We call them as complexes. Now, guys, these are the identity. Like this is how the complex compound look like. This M is the central metal atom, where L is standing for the ligands, Remember, guys, these ligands are electron pair donor. That means these ligands are Lewis bases, whereas the metal which is accepting those electron pairs, yes, into their d orbitals, yes, basically. So what are these, or s or p orbital as well, like if they're like empty orbitals, yes, they, as they can accept lone pair of electron, this metal atom ion like acts as a Lewis acid. Okay, guys, this can be like this is basically metal ion, and L stands for ligands. These ligands can be like negatively charged or neutral molecules as well. Guys, this is how the all, like, coordination sphere, this is how the coordination sphere look like if you ask this three-dimensional space occupied by the complexes is basically called as the coordination sphere, and this is how it looks like, where you can see this one is the central atom, and all these green one are actually the ligands, and how they are attached to the central atom axially as well as equatorially, isn't it? This is how it looks like. Don't worry, we are going to study them in detail now. Guys, why do we like how do this complexes look like? Just now I told you, a central metal atom bonded to a group of molecular ion is basically called as a metal complex. If it is charged, it is called as, yes, coordination sphere can be charged. In that case, it will be called as a complex ion. Compound containing complexes are basically called as coordination compound. Isn't it, guys? It can be octahedral, it can be tetrahedral, it can be square planar, it can be trigonal, bipyramidal, it can be square pyramidal as well. Okay, guys? Okay? Yes. Come on, guys. The very first question on the screen. Let us discuss it. By the time, all those who are watching, if you have not liked the video so far, do so. If you have not shared the video to all your friends, as I told you, like, please share the link to all your friends whom you know that preparing for NEET 2021, 2022, or preparing for J mains, advance, or board examination. Share the link to all of them, guys, because coordination chemistry is one of the most important topic of inorganic chemistry, and it is, yes, whether you talk about NEET weightage of inorganic chemistry, whether you talk about NEET or board examination or J mains or advances too much, yes, it cannot be ignored at all. It is one of the most important topic of inorganic chemistry. Yes, guys, and of course very interesting as well. Have a look at the very first question which we are going to discuss on the screen. Yes, guys, come on. Before we start, ensure you are not getting disturbed. Take a pen and copy and all your eyes on the screen. Let us read the question now. FeSO4, ferrous sulfate solution mixed with ammonium sulfate solution in a ratio of 1:1 molar ratio. It gives the test of Fe2 plus ion. Remember, when FeSO4 and ammonium sulfate solution, when they are mixed together in a ratio 1:1, it gives the test of Fe2 plus, test positive. But CuSO4 solution mixed with aqueous ammonia. Let us see the another example. CuSO4 solution when mixed with aqueous ammonia in a ratio of 1:4. This is 4, this is only 1. It does not give the test of Cu2 plus, test is not given by it, means it is negative. Why? Why does this happen? Can you tell me, guys? Yes. Because the first case is actually the case of formation of what? It is actually the case of formation of the double salt. Yes, guys, when these two are mixed in a ratio of 1:1 molar ratio, it forms a double salt. What does it form? A double salt, and double salt are represented with the symbol of the salt with a dot like this on the screen, as it is drawn on the screen. Have a look at the screen. So this is the double salt, and guys, double salt is something where the ions, I mean individual ion, metal ion, they do not lose their identity. Neither anions, they do not lose their identity. Therefore you will find that this particular complex do give the test of Fe, it does give the test for ammonium ion if conducted. Is that clear? Because it is a double salt. Now the second one, when this is mixed, copper sulfate and aqueous ammonia, they are mixed in a molar ratio of 1:4. What is going to happen, guys? What is going to happen? It is going to form a complex. Have a look at the screen, and all those who are watching, yes, if you know the answer, because today I'm going to have a lot of question. I have brought a lot of question for you to practice, guys. If you really know the answer, it would be better. If you really want to learn most out of this video, do one thing. The best practice is as the class is going live, so best practice it. Do answer in the chat box. I'm saying again, do answer in the chat box. Okay, guys, so it is going to form a complex. Is that clear? The complex so formed is going to be CuNH34 with a charge 2 plus. So you can say it is a complex ion, and this sulfate ion will further get combined, and it is going to form the complete complex will be represented this way. Okay, is that clear? Because copper is the form is present inside the, so, this coordination sphere, guys. Therefore, it is not going to give the test. This is the difference, or you can say the identity of a complex salt, that the ions, like metal ions, they lose their identity in the complex. So if you if you want to test copper, presence of copper ion in copper sulfate solution, this copper will give a positive test of presence of copper, whereas here the test for copper is going to be negative. It is going to give a negative test. Come on, let us look into the inbox. What is this inbox has to say? Let us see. Guys, in this case, double salt and coordination compound, that is complex salt. What is the difference between them? Guys, an aqueous solution of potassium alum will give the test for potassium as well as aluminium as well as sulfate. Why? Because potassium alum, which is represented this way, is basically a double salt where the ions do not lose their identity. Therefore, on dissolution in water, you will get potassium ion, you will get aluminium ion, you'll get sulfate, and you'll also get water of crystallization that is mixed with the water. Basically, if you want to test the presence of K plus or aluminium or sulfate, if you do the particular test, you are going to get all the three tests positive. All those who are watching have not liked the video so far, do so. If you have not subscribed the channel so far, do so. If you have not pressed the bell icon so far, do so. And one more thing, share the video as well to all your friends who are not only preparing for NEET 2021 or 2022, but also who are preparing for JEE Mains or Advanced, or like planning for improvement of board examination, or guys preparing for KVPY, or simply looking for their half-yearly examination or pre-board in the school. Do share the link to all of them. Have a look at the screen, guys. This is all about the double salt. It is very clear. Now, on the other hand, coordination compounds are molecular compounds that retain their identity even when dissolved in water. Yes, they retain their identity even when dissolved in water. Okay, guys, let us see. When potassium ferrocyanate is dissolved in water, it does not give the usual test of Fe2 plus or Cn minus, indicating that FeCN6 4 minus does not dissociate into Fe2 plus, and this is not going to ionize as this one. This will simply get ionized at, you will be getting potassium ion, and this ion you will never get it separated as Fe2 plus or Cn minus. Siddharth Chaudhary, welcome back to the class. How are you and how about your studies? Is that clear, guys? Is that clear? Is that clear? Come on. Have a look at the other question. Now, guys, the next question is explained with two examples, each of the following. Let us have a look on the screen. On the screen. The first question is, you have to explain about coordination entity. What is coordination entity, guys? Let us see that. What is ligand? What is coordination number, coordination polyhedron, homoleptic and heteroleptic? Let us discuss them all. Have a look at the screen. Jason B. Wesley. Hello, beta. Welcome to the class, Jason. How are you, Jason? And how about your studies? All those who are watching, don't forget to like the video. Don't forget to share the video to all your friends who are in class 11, 12, or prepare. They have taken dropper, preparing not only for NEET 2021 or 2022, but also preparing for JEE Mains Advanced. Looking for board examination, half yearly, yes, or KV. Share the link to all of them. And please don't forget to like the video as well. So guys, so let us have a look at the screen. What are ligands? Ligands, guys, are those species which have a tendency to donate lone pair of electron. They are basically Lewis bases. Okay, they are basically Lewis bases. They can be neutral, they can be negative. They can be negatively charged like Cl minus or OH minus, or they can be neutral ligand like water or ammonia also, or ethylene diamine, guys. Now what is coordination entity? The square all the metal ion and the ligand present inside that, this together is called as coordination entity. Is that clear? Coordination sphere or coordination entity. You can see in this case everything is present inside the coordination sphere. Now have a look, what is coordination number? Guys, coordination number is basically the number of ions or ligands which surrounds the metal ion in the coordination sphere. I'm repeating, coordination number is basically the number of ions or the ligand, basically the ligands which can be ions, which can be neutral molecule surrounding the central metal atom. For example, in case of K2PtCl6, there are 6 chloride, and you can see there are 6 chloride ion which are surrounding the central metal atom platinum over here. Therefore 6 is the coordination number of platinum. As platinum is surrounded by 6 chloride ion, therefore the coordination number of platinum here is 6. Now in this case, nickel is surrounded by 4 ammonia molecule. Therefore coordination number of nickel is 4, guys. The coordination number of central metal ion, that is nickel, is 4. Is that clear, guys? Now the next one, coordination polyhedron. I'm repeating, coordination polyhedron is the spatial position, three-dimensional space occupied by, I'm repeating, it is basically the three-dimensional space occupied by the coordination compound. Guys, it is spatial positioning of the ligands that are directly connected to the central atom in the coordination sphere. For example, just have a look at this. This is a tetrahedral complex. Can you see this? This one is a tetrahedral complex. Now this dotted line is actually representing the polyhedron. I'm repeating, the dotted line is actually representing the polyhedron. Is that clear, guys? Dotted line. Here, this is a square planar. Guys, the dotted line is actually representing the polyhedron over here. So what is a coordination polyhedron? I'm repeating once again. It is the spatial positioning of the ligand that are directly connected to the central atom in the coordination sphere. For example, guys, this one is this pen might be the central atom. So whatever the ligand, it is surrounded to different ligands. So polyhedron, yes, the polyhedron is three-dimensional space occupied by the coordination compound. Is that clear? Is that clear, guys? If you are getting it straight away here, do one thing, like the video. Another thing, share the video if you have not done so. And if you have not subscribed the channel, Let's Crack NEET UG in English, do so. Do press the bell icon. And one more thing, guys, one more thing. This is our Telegram ID as well. You can join us with the Telegram ID. Let's Crack NEET UG in English. The same name, no confusion, isn't it? Okay, guys, have a look at the heteroleptic. They are the complexes with their metal ion being bonded to more than one kind of donor group. You can see in this case, cobalt is bonded to ammonia as well as Cl. So more than one type of ligand are there. Therefore, it is heteroleptic. Is that clear? Is that clear? Guys, this is homoleptic. You can see here CO, carbonyl is there. So this will be homoleptic. All done. Homoleptic. Here you can see all platinum is surrounded by only chlorine, so it is homoleptic. In this case, it is surrounded by only ammonia. Therefore, this is also homoleptic. Okay, all clear, guys? Yes. Have a look at. So it is very, very clear what ligands are. What is coordination entity or coordination sphere? Yes, all clear. What is coordination number? What is coordination polyhedron? What is heteroleptic? What are homoleptic complexes? What are heteroleptic complexes? I hope it is all clear. So this particular one is also like cobalt. Cobalt is having this C will be bigger. Cobalt is having chlorine as well as ammonia. So it is also what? It is also what? Heteroleptic, where this is homoleptic. This particular one is also homoleptic. This is also homoleptic. All clear, guys? All clear? Let's have a look on the next question. By the time, all those who are watching, if you have not liked the video so far, do so. If you have not shared it, do so. If you have not subscribed it, the channel, do so. If you have not pressed the bell icon, do so, guys. Now the next question is, what is meant by unidentate, bidentate, ambidentate ligand? Dentate, guys. First of all, let me tell you the meaning of dentate. Suppose, guys, this is the central metal atom. Done. This is the central metal atom. Okay. Denticity means this is the denticity. Or suppose this is the ligand. How it is attached to, how it is attached to the central atom is actually denticity. ओके डेंटिन दांत होते हैं ना दांत जस्ट दांत चुभाएगा इसमें with the how this दांत I mean teeth is going to pierce into it with the terms of coordinate bond. Yes, it is going to make a coordinate bond by donating its lone pair of electrons to the central metal atom. So that formation of a you know uh, coordinate bond is basically called as denticity. Is that clear? Denticity. Okay, denticity. दांत चुबा के hold karna, get holded to the metal ion. Okay, if it is unidentate, it is very clear from the name itself. Uni means what? One. Bi means what? Two. Ambi, that is from like only one, but from two sides. Ambi, from any sides, from two sides. I'm going to explain this, don't worry. From two sides, from, but at a time, actually from only one side, but it can be attached like this or can be attached this way, either from this way or from this way, that way. Okay, that is the meaning. Or take it this way, if it is ambidentate means either it is going to get attached to this, this is the ligand which is ambidentate. What does that mean? Either will be attached to the metal atom from one side, from this one, or it can be attached to the metal atom from this side. Ambi, from any, from two side, but at a time only from one side. Is that clear? Let us look with this examples on the screen. Unidentate, guys, it is very, very clear that if it is unidentate, these ligands with one donor side, they will be having only one donor side. If you talk about Cl minus, or you whether it is negative or neutral, guys, it will have, yes, it will have only one donor side. At a time, these ligands are going to share their only one lone pair of electron. That is the meaning of this one donor side. Is that clear? Is that clear, guys? Come on, have a look at the screen now. Guys, there are many more examples of unidentate ligand. What are that? Yes, all these are the example. For example, water, ammonia, NO2 minus, SCN minus, OH minus, all halides minus. Yes, all these are what, guys? All these are going to donate only one lone pair, or they are having only one donor side. Therefore, they are called as unidentate ligand. Is that clear? They are called as unidentate ligand. Done? Now let's have a look at ambidentate ligand. Ambidentate ligand are there, guys. For example, nitro and nitrite 2. Nitro and nitrite 2. You can see nitrogen has got a lone pair over it. So these are ambidentate, both of them. NO2 minus is basically ambidentate. How come? If it is nitro, guys, remember, if you call it as nitro, it is going to that donor side is actually the lone pair present on nitrogen. Okay, so it is going to attach to the central metal atom by its nitrogen atom. Or in case of nitrito, you can see there is a negative charge over here. So if this is going to attach to the central metal atom by this side, it is going to be nitrito. Is that clear? So nitro and nitrito are ambidentate ligand. So what is the definition? These are the ligands that fasten themselves to the central metal atom or ion via two different atom. I'm repeating, via two different atoms. For example, NO2 minus or ONO minus. Same, this is also bidentate, I mean ambidentate ligand, guys. Cn minus, it can get attached to through this nitrogen side or through carbon side. Is that clear? Similarly, this SCN minus also a bidentate ligand, either SCN minus or NCS minus. Yes, these are all what? Not bidentate, I'm so sorry. Ambidentate. Ambidentate means what? From two sides in the same ligand. Okay, this case you can see from here nitrogen or oxygen. In case of Cn minus or Nc minus, either from carbon or nitrogen here, either from nitrogen or, yes, yes, is that clear? So there are two sides, okay, in the same ligand. Therefore, they are called as ambidentate. Ambidentate. Is that clear? Now let us have a look at bidentate ligand. Guys, one of the example is there in the inbox. You can see ethylene diamine. Ethylene diamine. You can see that nitrogen has got a lone pair. Through that lone pair, it gets attached to metal atom, central metal atom. So there are two sides, two donor side. I'm repeating, there are two donor side. Therefore, it is called as bidentate ligand. One more example. In fact, there are many more example, guys. One is there oxalate. Oxalate, guys, COO minus, COO minus. So these are the two side, two donor side from the two oxygen. Is that clear? Therefore, this is also called as bidentate ligand. All those, yes, 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 who want to answer, because question is there on the screen. Guys, if you really want to answer, if you really want to get most out of this video, why don't you answer in the chat box? That is going to help you most, trust me. Yes, yes, guys. Or if you have any doubt, you can ask me in the chat box related to the topic being taught on the screen now. Yes, and if all other doubt, if you really want to ask tomorrow I always keep a doubt session Sunday evening at Unacademy platform. If you really want to be a part of that, do one thing: download the Unacademy learning app, not the educator app. Unacademy learning app. Download the Unacademy learning app. All done. And then just click on to Sharda the educator application, and then get connected to me and ask all your doubts, whatever is there. Okay, guys. Okay, have a look at the screen now, and if you have any doubt related to the topic being taught now, please ask the doubts in the chat box. Okay, guys, have a look on the screen. Specify the oxidation number of the metal in the coordination entity. Come on, guys, this coordination compound, there are different type of questions, and one type is, see, guys, one type is to tell you to to find out the oxidation number of the metal. I'm repeating, one type of question is also mostly asked, what is the oxidation number of the metal in the given coordination complex or the complex coordination ion. And also, guys, this finding oxidation number is very important, because without that you will not able to write down the, you will not able to write down the correct IUPAC name, because very soon we are going to discuss how to write down IUPAC names of the coordination compound. There you'll come to know that it is really important to know the oxidation number of the central metal atom. Is that clear? Is that clear, guys? Have a look at the first one. Specify the oxidation number of the metal. Identify the metal atom over here. Cobalt. It is very clear. It is very clear that it is cobalt. The ligands. Now identify the ligands and specify their charges. Guys, let the oxidation number of cobalt be X here. H2 is a neutral ligand, therefore it will have 0. Whereas Cn minus is a negatively charged ligand, therefore it will have -1 charge. Is that clear? And again, guys, ethylene diamine, just now you had seen there was no charge over it, so it will also be 0. And guys, this is a complex cation. Yes, the charge on the complex, the net charge on the complex is plus 2. How much the net charge, guys? It is plus 2. Is that clear? Is that clear, guys? Come on. So let us see the sum of all the oxidation number is plus 2. So let us see how it is to be calculated out. It will be simply x plus 0, then minus 1, then plus 0. The sum total is plus 2. Okay, guys, so it will be x equals to plus 2, and this minus 1 will go to that side, will become plus 1. So together it comes out to be how much? Yes, how much? It is 3. How much it is? 3. Is that clear, guys? So together it is coming out to be 3. All done? Clear है guys? Clear है? समझ में आ रहा है? Now have a look at the screen. In this case, guys, let this be x. Bromine is minus 1. Yes, for 2 it will be minus 2. Ethylene diamine 0. And the net charge on this is what? Net charge on this is plus 1. All done. Let us solve this, guys. Let us solve this. X minus 2, because 1 bromine is minus 1, 2 bromine has to be minus 2. For ethylene diamine it is 0. By the time if you all guys are watching it and calculated, please reply in the chat box. I'm waiting for your answer, because that is, yes, if you participate in it, it is going to help you guys. So it will be x minus 2 plus 0. I'm repeating, it will be x minus 2 plus 0 is going to be plus 1. Is that clear? And x will be plus 1 plus 2 comes out to be plus 3. All clear, guys? Now let us have a look at the screen for the third one. Let it be x. Chlorine is minus 1. Okay, guys, and net charge is minus 2. It should be x minus 4 equals to minus 2, or x coming out to be minus 2 plus 4, that will be plus 2. Is that clear, guys? Now let us calculate for this one. Guys, there are two spheres. This is coordination sphere, this is ionization sphere. For potassium it is plus 1 always, alkali metals plus 1 always. Let the oxidation number of iron is x, that of Cn is minus 1. So add it all together, guys. Either you can take over here and net as 0, or you can ionize it as, you can do anything. FeCN6. On ionization, the complex is going to have a minus 3 charge. All clear? So let it be x minus 6 will be minus 3, or x will be coming out as plus 3. If you have solved, well done. If you have solved, you can answer in the chat box. Okay, guys, is that clear? Now, okay, I've started. Yes, guys, come on, have a look at the screen. Chromium is what? Chromium is, let it be x. Ammonium is 0 because it is a neutral ligand. Chlorine is minus 1. If you have solved, do reply in the chat box. I'm repeating. Do reply in the chat box. Okay, guys. Okay, is that clear? Have a look at the screen. This will be, what is the net charge on the complex, guys? Overall charge is nothing. There is no charge, so it will be what? Let it be x plus 0 minus 3 is equal to 0. So x has to be what? Plus 3. Is that clear? X has to be plus 3. All clear, guys? All clear? Well done. No, beta, no worries. Okay, kabhi galat hoga, kabhi sahi hoga, but you all should keep trying. Have a look at the screen. By the time I'm going to have few sip of water. Now, guys, let us have a look at the next question. Using IUPAC norms, write the formula for the following. Okay, guys. The first one is what? It is tetrahydroxydozincate 2. I told you guys how important the oxidation number are. And always remember that in case while writing the IUPAC name, we always specify their oxidation state in a Roman numeral inside the bracket just beside the metal ion. Is that clear? So guys, what is the name of this? Tetrahydroxydozincate 2. First of all, guys, as zinc is not simply named as zinc. It is added with the suffix "ate." That means this is an anionic complex. I'm repeating. This is an anionic complex. All done. First thing, tetrahydroxidozincate. So it will be Zn, tetrahydroxo, OH4. And yes, guys, because the complex is what? It is an anionic complex, therefore it has to be 2 minus. This way, the formula will be written. So, okay, is that clear? Is that clear? Now have a look here at the second one, potassium. This is about potassium will always be in the ionic sphere. So, potassium, then make the coordination sphere. Tetrachlorido palladate. 2. Palladate again, this is what? Anionic. This will go into anionic part. Tetrachlorido means Cl4. PD. Is that clear? 2. It is very, very clear that if it is PD2, it has to be this anionic complex should have a 2 minus charge. Is that clear? Therefore, the 2 will be here. Are you getting this? 2 minus charge over here. 2 minus charge over here, therefore that 2 will be written with this. Okay, so it will be K2. Are you clear? Are you getting this? So the complex correct formula of the complex will be what? K2PdCl4 palladate. Is that clear? Date, 8 suffix is always added to the metal, ion, when it is present in the anionic part or anionic complex. Is that clear? Now, those who are watching, if you have not liked the video so far, do so. If you have not shared the video so far, do so. Have a look at the screen. Diamine dichlorido platinum 2. If it is simply platinum, means what? It is a cationic complex. Are you getting this? In earlier cases, the suffix 8 was there. Therefore, they all were what? They were present in the anionic sphere or, coordination sphere. As it is, like this is also, in fact, anionic part. Okay. And as in the third case, it is simply platinum. Therefore, what? Potassium tetracyanide. Yes, sorry. The third one. Have a look at the third one, guys. It is simply diamine dichlorido platinum 2. I'm repeating, diamine dichlorido platinum 2. That means what? This platinum is present where? Either in the anionic part or simply the neutral one. Is that clear? Or positively charged one. Is that clear, guys? Is that clear? Let us have a look now. Diamine. Make it diamine. NH3 whole twice. Dichlorido, let it be Cl2, and then what? Platinum. Write down platinum here. Okay, is that clear, guys? There is no charge over here. Simply, it is what? It is what? A neutral compound or the cationic part. It will be simply named as platinum. And in this case, as it is platinum 2, means the whole, there is no charge over it. Why? Because platinum is in +2 oxidation state and that is getting neutralized by 2 chloride ion. Is that clear? Is that clear, guys? Now the next one is potassium tetracyanidoniculate 2. I'm repeating, potassium tetracyanidoniculate 2. It's very, very simple, guys. Make it potassium, right? Potassium. Make a coordination sphere. Tetracyanido, that is CN4. Is that clear? CN4. Tetracyanidoniculate. This will be tetracyanido. Is that clear? Potassium tetracyanidoniculate 2. Nickelate 2 means the CN is going to have -4. So the complex is, because it is in +2 oxidation state, therefore the complex will be having a -2 charge. Therefore it will be K2. Is that clear? That -2 will be written over here as a subscript. K2 NiCN4. Is that clear, guys? All those who are watching, do like the video. Do share the video, guys. So this is the formula. This is the formula done. Now the next one is pentaamine nitrito O oxygen cobalt 3. Is that clear? Let us write down pentaamine, guys. NH3 whole 5. I'm repeating. This will be pentaamine. Are you getting this? Is this clear? Pentaamine. Then what? Then nitrito. Simply write down NO2. Okay, guys. Nitrito. Okay. Just a sec. Yes, guys, have a look at the screen. Pentaamine nitrito, guys. Let me take an eraser because O is there. Guys, if it is O is there, this nitrito will be written as ONO. Are you getting this? ONO. Why? Because it is being attached to O. The ligand ONO, as it is an ambidentate ligand, it is connected to cobalt from oxygen. Is that clear? So it will be NH35ONO. And what is cobalt? Write it cobalt. Guys, cobalt is in which oxidation state here? It is in plus 3 oxidation state. What does that mean? Plus 3 of this minus 1 of this means it is a cationic complex, guys. And in order to balance the charge, this complex, cationic complex, must have a plus 2 charge. Because cobalt is in a plus 3 oxidation state, ONO is minus 1. So plus 3 minus 1 has to be what? Plus 2. Therefore, it is a cationic complex with the charge of plus 2. Is that clear? Clear, guys? Now let us have another question, guys. Another question is simple. Hexaamine cobalt 3 sulfate. Hexaamine, guys, hexaamine NH3 whole 6, all done. Cobalt, yes, cobalt 2. No doubt, ammonia is a neutral ligand. So cobalt 2, 2 plus charge is there on the complex because of the cobalt. So, and sulfate is there. That 2 plus will be neutralized by a sulfate ion. So this is how the complex will be represented. Is that clear, guys? Hexaamine cobalt 3 sulfate. All clear, guys? All clear? All clear? Okay, but remember, guys, this is cobalt 3. Come on, this is 3 plus and this should be 2 minus. Therefore, yes, we'll have to go for a cross like this. This will be 3 over here by the bracket. This 2 will go over here. Are you getting this? Because cobalt 3 is there, guys. Guys, so the formula will be written as yes, hexamine, NH3 whole 6, cobalt 3, guys. Therefore, sulfate whole thrice and iska minus 2 will be written over here. So this is the correct formula. So this is how you can see that oxidation states are very important, isn't it? Oxidation states are very important, guys. Now the next one, potassium trioxylatochromate 3. Potassium is there. If it is potassium, it will be always written as in the ionic sphere, ionization sphere. Trioxylato is a bidentate ligand, C2O4 whole thrice because it is trioxylato, and chromium 8 is there. That means it is an anionic complex. It will be as an anion, complex anion. Is that clear? Now let us balance the charges, guys. How many potassium will be there? Okay, it's very simple from here. Guys, the charges due to oxalate is minus 2 as trioxalato. So it will be minus 6 plus 3. So net charge over this is 3 minus that 3 will be written over here. So the formula of the complex is going to be K3CrC2O4 whole thrice. Is that clear? Clear? All done. Have a look at this one. Hexaamine platinum 4. Very simple. Hexamine, so NH3 whole 6, the complex. Okay, platinum 4, guys, as the charges has to be balanced and ammonia is having a zero charge. That means what? That 4 plus charge should come over here. That means this is a cationic complex. Okay, guys, because platinum is in plus 4 oxidation state, that plus 4 will be represented over here because ammonia is a neutral ligand. All those who are watching, do like the video, dear. Do like and do share the video. If you are really finding this video very helpful, interesting, do like the video. Now, guys, the next one is tetra bromido cuprate 2. 8 is there. That means it is an anionic complex. Be very particular for this. Okay, guys. Now, tetra bromido means Br4. Tetra bromido. Cuprate means it will be copper. And guys, it is there, therefore it must have what? A negative charge. Copper is in +2 oxidation state, bromine is -1. So there will be 4 minus and +2. The net charge over this will be -2. And it is very clear from the name itself that it is an anionic complex. And the charge over that anionic complex will be -2. Why? Because copper is in +2 oxidation state and 4 bromine का क्या हो जाएगा? -4. -4 plus 2 has to be equal to -2. That -2 charge will be present on the complex anion like this. All clear? Now have the last one over this under this question. Pentamine nitrite to N cobalt 3. Very simple, guys. N means what? That NO2 is attached to the metal ion through amine. It will be NH3 whole 5. All clear? Pentamine nitrito, simply NO2, guys. Is that clear? It will be pentamine nitrito. The complex will have what inside this? Cobalt. Is that clear, guys? And it is +3 oxidation state. It is very, very clear that it is +3 oxidation state. Guys, +3 of this, -1 of NO2. The net charge is +2. Therefore, this is a cationic complex with a +2 charge over this. I hope you guys are able to make out how to find out the charge or how to make out whether it is an anionic complex or cationic complex. Is that clear? Clear? Well done. All those who are watching, do like the video, do share the video to all your friends who are preparing for NEET 2021, 2022. As well, you can share to them who are preparing for J Mains and Advanced. Well done, Ravi. Welcome to the class. How are you and how about your studies? Yes, guys, have a look at the next question. Now, the previous question was I from IUPAC name. You were supposed to write down the correct formula. In this case, formula is given. You have to do what? Yes, you have to write down the IUPAC name. Okay, guys. Yes, Ravi. Yes, beta. What do you want to say? Do let me know in the chat box, beta. And welcome to the very, very own channel of yours. Let's crack NEET UG in English, where you'll be taught in English. Isn't it, Ravi? Do let me know if you really want to know something else. Okay, guys, have a look at the screen. What is the IUPAC name of the following one? Ravi, do answer in the chat box. Yes, beta, it is all free. It is all free, dear. It is all free. Okay, yeah. Have a look. This channel, yes, access to this channel is all free. Come on, have a look at the screen. Guys, what is the name of this one? CONH3 whole 6 and Cl3. This is ionization sphere. Cl is present in the. Yes, but it is free. Yeah, it is free. Okay, have a look at the screen, Ravi. Now let us see how it is to be named, guys. Have a look at the screen and let us see how it is to be named. Okay, guys. Now, guys, it is very, very clear from here that yes, this will be named as how many amines are there? 6. So let us start with the ligand's name. Always remember, guys. If ionization pair is a cation, then the name will be started with a cation. Okay, and in this case, ionization sphere is an anion one, so the name will be ending with the name of the chloride one. Is that clear? Now, secondly, whenever we name the complex, we always name it with the name of the ligand. Well done, Ravi. Well done, Ravi. This like is for you, dear. Well done. So, and one more thing, guys. First of all, in order to write down the IUPAC name, you should know the oxidation state. I told you how oxidation state are very, very important. All those who are watching, do like the video, do share the video. So let us find out the oxidation number. Okay, no, beta Ravi, it's all your hard work, dear. Let the oxidation number of this is 0. I mean X, sorry, not 0, X. For ammonia, we know that it is 0. For chlorine, it is -1. Okay, guys, okay. Now, guys, the complex is going to have a minus charge over this. Okay. Let it be X plus 0 minus 3 is equal to 0. Okay, because we have included this also. Either you can do this, or you take the complex as CONH3 whole 6. To that there will be a charge of how much? Plus 3. You can take this will be x plus 0 is equal to plus 3, or x is simply plus 3. If either you can do this way, or simply just put on the oxidation number of all like this. Okay, minus 1 on each chlorine, so there will be minus 3. Is that clear? All those who are watching, do like the video, please like the video. Now guys, it will be what? X plus 0 minus 3 equals to 0, so x will be plus 3. Is that clear? X is going to be plus 3. Now let us see how it is to be named. Okay, so the name is going to be started with the name of the ligand, that will be hexaamine. Is that clear? It will be hexaamine, because the ligand has to be named first. Only one ligand, homoleptic complex. So hexa, 6 ligands, 6 amines are there. So it will be hexaamine. Then cobalt, and then write down its oxidation state in a Roman numeral. Maler Janvi Pagoda. Welcome to the class, beta. Maler Janvi, how are you, dear? And all those who are watching, do like the video. Do like the video, guys. Do share the video. Well done, beta. These 2 likes are for Maler. Well done. Your answer is all correct. No, beta, it's all your hard work, dear. It's all your hard work. Well done. Okay, okay, have a look at the screen now. Have a look at the screen, guys. Now it's very, very clear from here. All those who are watching, do like the video. It is very, very clear that you guys are participating in the answer. That means I'm getting very, very energetic now. Okay, okay, guys, well done. All those who really, okay, you are my old student. Welcome to the class. I'm so happy to see you, beta. Malir Janvi Pagoda is saying, ma'am, I'm your old student. Really nice of you, beta. Really nice of you. Okay, how about your studies going on? Do reply in the chat box. By that time, all those who have not liked the video, do so. Do share the video. So it will be, guys, hexaamine cobalt. As I told you, you are supposed to write down the oxidation state in Roman numeral, and that is 3. Just now we had seen. And then write down the name of the anionic complex. Anionic, I mean species, that is chlorine, will be written as anionic name of chlorine is chloride. So it will be simply written as chloride. Is that clear? Is that clear, guys? Is that clear? Now the next one will be find out the oxidation number of platinum, and do reply in the chat box. All those who are watching, find out the oxidation number of platinum in this one, and do reply in the chat box faster. Just a sec. What's gone wrong here? Okay. Yes, guys, find out the oxidation number. I'm waiting for your reply in the chat box. Yes, come on, guys. Now, guys, let it be X. For ammonia, it is 0. For chlorine, it will be minus 1. Will it be? Will it be, guys? Now, in this case, this will be what? This will be NH2CH3. Yes, 0. So, guys, the charge on this, let it be X minus, yes, how much it is? X minus 1, because all are 0, so let it be x plus 0 plus 0 minus 1, 0 for this one, and together, guys, minus 1 for this, together comes out to be 0, or x will be plus 2. Is that clear? X is going to be plus 2. All those who are watching, do like the video. Now let us see how it is to be named. How it is to be named, guys. Very simple. Yes, this is a cationic complex, so name will start with the name of the ligand, isn't it? Well done. 2 likes are for Maler Janvi Pagoda. Well done, beta. 2 likes for you. Well done. Your answer is very, very correct. So the name will be diamine, because diamine are there. And remember, we have chloride, we have amine, and we have also methylamine. This ligand is named as methylamine. Methylamine starts with the letter M, chloride starts with the letter C, and amine starts with the letter A. So alphabetically, you have to name all the 3 ligands in alphabetical order. So it will be diamine. Done. A comes first, then C, that is chlorido, diamine chlorido, and then M guys, so methyl amine, all done. Diamine chlorido, methyl amine, and then platinum. As it is a cationic complex part, so it will simply be platinum. And inside the Roman, just find out the charge platinum 2 and then simply write chloride. Is that clear? So the IUPAC name of this one is diamine chloride methylamine platinum 2. This will be what? Chlorido. Diamine chlorido methylamine platinum 2 chloride. Remember guys, this chlorido, the Cl is present inside the coordination sphere, whereas this Cl is present outside the coordination sphere. I hope you are straight away getting it here. I'm getting so many answers. I'm really, really very happy to see these many answers. All those who are watching, do like the video, do share the video, and please participate in answering. Answer in the chat box, guys. Yes, yes, yes. What is the oxidation number of this titanium? Let it be X. That of water is 0. So it is going to be X is equal to plus 3. Very simple, isn't it? Simply plus 3, guys. And name is also simple because there are simply 6 water molecules. Is that clear? So the name of this one simply will be hexa. As 6 are there, and H2O is named as aqua. Hexa aqua titanium. In Roman, it will be simply 3 iron because it is a cation, guys. So iron has to be named over there. Okay, so nice, guys. All your answers are correct. 2 likes are there for you. So, guys, come on. All those who are watching, do like the video if you have not done so. Do share the video if you have not done so. Do subscribe the channel. Let's crack NEET UG in English if you have not done so. Do press the bell icon if you have not done so. Guys, this let it be X. This is 0. This is minus 1. NO2 is taken as minus 1. Chloride is minus 1. So the oxidation number over here will be X plus 0 minus 1 minus 1 minus 1 should be 0. So X will be coming out as plus 3. Is that clear, guys? So what is the name? Remember, there are how many ligands? Amine, chlorido, and nitrito. Guys, nitrogen, it is attached to nitrogen side. So alphabetically, you have to compare the letter N. So nitrido, C for chlorido, A for amino. Amine as well. So yes, write down them in alphabetical order. I'm repeating, write them in alphabetical order. Is that clear, guys? Is that clear? Let us write down Sai Karthik Giddy Jala. Tetraamino, well done. Tetraamino, well done. You guys have started participating in it. Really, really, I'm so happy to see your answer in the chat box. Welcome to the class, Karthik Gidizala. Welcome to the class. How are you, dear? And how about your studies? And all those, if you have not liked the video so far, do so. If you have not shared the video so far, do so, guys. Do so. Come on, have a look at the screen. Guys, this will start with tetraamino. Well done. This will start with, yes, the name of this one will be tetraamino. Then A, after that C, alphabetically it is C. So tetraamino chlorido. Then nitrito. Nitrito. All clear? Dash N, because through nitrogen it is attached to cobalt. Gidizala, chlorido. Well done, Gidizala. Karthik Gidizala, your answer is absolutely correct. Tetraamino chlorido, nitrito, N. Then write down what? Cobalt. Then guys, N dash, it will be N dash cobalt. Remember, this N is representing that this nitrito NO2 is attached to cobalt through nitrogen. Cobalt. Is that clear? Then simply write down the oxidation number 3, which is coming, which just now we had calculated as 3, and then write chloride. So this particular complex will tetraaminochlorido and cobalt 3 chloride. Is that clear? Is that clear, guys? All those who are watching, if you have not liked the video so far, do so. If you have not shared the video so far, do so, guys. Do so. Come on, have a look at the screen. Now, guys, how it is to be named? First of all, find out the oxidation number. X, and that of water is a neutral ligand, so it will be 0. It is coming out to be the net charge over the cationic complex, and that is plus 2. So the oxidation number of manganese is plus 2. Is that clear, guys? So how it will be named, guys? It is simple. There are 6 water molecules. Therefore, this will be named as hexa. And for water, just now I told you, you use the term aqua. So it will be hexa aqua. I'm repeating, hexa aqua, and Mn is manganese. Simply cationic complex, so manganese. Manganese inside the bracket, Roman 2. Then iron. Is that clear? Now this one is an anionic complex, guys, because there is a -2 charge. Well done, Karthik. Your answer is absolutely correct. Let this oxidation state of nickel be X, and that of fluorine is -1. So, guys, it will be X minus 4 coming out to be -2, or X will be simply +2. So, nickel is in +2 oxidation state. Is that clear? So, guys, there are 4 chlorine, so it will be tetrachlorido. I'm repeating, this will be tetrachlorido nickelate, because nickel is present in an anionic complex. Well done. Karthik, your answer is absolutely correct. 2 likes are for you to giving so answer the answer so promptly. Yes, well done, beta. Then, guys, nickelate. Nickelate. All done. Inside the bracket, Roman 2 +2 charge, so it will be Roman 2 iron. I'm repeating, tetrachlorido nickelate 2 iron. Clear? Clear, guys? Now this nickel must be X. Let it be X. This ammonia is 0, and this chlorine will be -1. Let us see how this particular one is named. First of all, find out the oxidation number. It will be X plus 0, X plus 0, then -2 should be 0, or X is coming out to be +2. Is that clear, guys? Is that clear? Let us see how it is to be named. Simply, guys, there are 6 amine, therefore it will be hexaamine. Yes, it will be hexaamine. Are you getting this? Then what? Nickel. Nickel, simply nickel. Why? Because it is a part of the cationic complex nickel. And coordinate, oxidation number is 2. So Roman 2, and simply then chloride. Simply write down chloride. Is that clear? Well done. 2 likes for you. Your answer is absolutely correct, Karthik Gizala. All those who have not liked the video so far, please like the video. Please share the video. Okay, guys, have a look at the screen. Now, guys, the next one. This ethylene diamine. And how many ethylene diamine are there? Guys, there are 3. And this is a bidentate ligand. Remember, guys, for bidentate ligand, if their number is 1, it is simply mono. If it is 2, it will be bis. If there are 2 by such bidentate ligand, it will be bis. Or if it is 3, like in this case, the prefix added to the name of that ligand will be tri. Will be tris. It will be tris. There are 3 ethylene diamines, so it will be tris. Is that clear? Let us see how it is to be named. But before that, let us find out the oxidation number. Let it be X. This will be 0. So X is equal to +3. The oxidation state of cobalt in this complex is what? It is +3. Let us see how it is to be named. I told you guys ethylene diamine is a bidentate ligand, and there are 3 such ligands. Therefore, the prefix tris will be added. It will be tris ethane 1 2 tris ethane -1 2 diamine. Okay, close the bracket. Then cobalt. Then oxidation state in a Roman numeral, which is 3. And simply iron, because it is a cationic complex. All done. All done, guys. Is this clear? Now the next one, guys, carbonyl. This is zero oxidation state and nickel is X. So there, what is the oxidation state of nickel? Can you tell me? Very, very important, guys. CO, there is no charge over it. So what is, simply it will be tetracarbonyl. The oxidation state of nickel will be zero. It will be tetracarbonyl nickel zero. Very simple. Tetracarbonyl nickel zero. Is that clear? Is that clear, guys? Now let us go ahead. All those who are watching, I'm repeating, all those who are watching, do like the video. All those who are watching, do like the video. If you have not done so, all those who are watching, well done. The hybridizations are, Karthik has told me that the hybridization is, yes, for which, beta? But I'm so happy that you have participated in the, yes, in the chat box. On the try to answer the question. All those who are watching, do like the video, guys. If you have not done so, do share the video. If you have not done so, I'm waiting for the answer to the question on the screen. Do reply in the chat box. No, beta. No, it is simply SP3. Yes, it is DSP2. Well done. Think over that. It will be SP3, beta. It will be sp3. Think over that. Okay. Of course, carbonyl is a strong ligand. Therefore, because oxidation state 0, therefore 4s2 electron will also enter into 3d orbital. Is that clear? And then it will be hybridization required over here will be sp3. Is that clear? Karthik, is that clear? All those who are watching, if you have not liked the video so far, do so. If you have not shared the video so far, do so. And please answer the question in the chat box. Come on, guys. By that time, I'm also trying to solve this for you on the screen. What is a coordination entity formed? I'm repeating. What is a coordination entity formed when an excess of aqueous KCN is added to an aqueous solution of copper sulfate? Why is it that no precipitate of copper sulfate is obtained when H2S is passed through this solution? No problem. Let us see. Excess. Guys, what happens? Copper sulfate. What is the formula for copper sulfate? Let us have a look here on the screen. Copper sulfate solution means copper sulfate aqueous. Excess of aqueous KCN means what? KCN is added to this. I am repeating. Have a look at the reaction. KCN is added to this, guys. Okay. Now, to KCN, when less KCN is added, initially what is going to happen? Guys, initially it will form CuCN whole twice, done, plus K2SO4 will be formed. All clear? This CuCN whole twice will soon form or will soon get convert into Cu2CN whole twice and dicyanogen gas you will be getting. Okay, okay, guys. On adding KCN excess, this together will form the complex K3CuCN4 like this. Well done, beta. Well done. These 2 likes are for you for answering it correct. The video if you have not done so. So because of this complex, you can see, guys, copper is present in the coordination sphere. And CN is a strong ligand, of course. Guys, the complex is highly stable. This complex is highly stable because CN is a strong ligand, as it is the part of the complex, isn't it? So does not dissociate or ionize in order to give precipitate with sulfur on addition of H2S. Therefore, there is no precipitate. Is that clear? Or you can say copper is a part of what? It is has lost its identity. It will not come out of the coordination sphere. Therefore, it will not get precipitated with H2S. Is that clear? Complex sign. no further dissociation of copper ion, therefore there will not be no precipitation found of metal sulfide. Yes, yes, one is the coordinate bond or dative bond from oxygen towards carbon, and there is a lone pair present on carbon like this. Because of this lone pair, they act as a Lewis base or a best ligand, guys. Yes, carbonyl are the best ligand, strongest ligand, isn't it? Now, guys, suppose this is the metal ion. Okay. First of all, this lone pair is donated to the metal atom. Ma'am, network issue is there for me. Okay, okay, beta. Do one thing, refresh a bit. Janvi is saying network issue, beta, refresh because my system is all okay now, beta. Okay, and all those who are watching, do like the video. If you have not done so, do share the video, guys. This is how the sigma. This is the sigma bond. Okay, in turn, what happens in return to this, guys? In return to this, the filled orbital, remember this filled orbital of carbon forms a sigma bond with the empty orbital of metal. In return, the filled orbital, I'm repeating, the filled orbital of metal atom forms a pi bond like this. There is a pi bond. Okay, the filled orbital this way, guys, from metal to yes, electron goes from here in the pi bond, guys. In the pi bond formation, electron goes into pi anti-bonding molecular orbital of the CO, carbon of CO. Is that clear? Yeah, sure. Download the lecture. You can watch it. Yes. You can record it, download it. You can watch it from there. Okay, guys. Okay, have a look at the screen. Is that clear, Janvi? Now have a look at the screen. So, guys, it is very clear that from ligand to metal, the sigma bond, from metal to ligand, it forms a pi bond. Is that clear? So, let us read this. A sigma bond forms when a lone pair of electrons are donated to the empty orbital of the metal by the carbonyl carbon. Just now we had seen. A pi bond forms when a pair of electrons are donated to the empty anti-bonding molecular orbital of the carbon by the filled d orbital of the metal. This is from filled d orbital of the metal. So it is type of d pi p pi. Yes, this entirely stabilizes and strengthen the metal ligand bonding. Is that clear, guys? Metal ligand bonding. Is that clear? It is very clear from here. So, guys, there are two type of bonds: sigma overlap and pi overlap. Sigma overlap, donation of lone pair of electron on carbon. Yes, lone pair, donation of lone pair of electron by carbon. Make it by carbon. Okay, well done. It is clear. Well done. So nice of you. By carbon, guys, into a vacant orbital on the metal. The second one, pi overlap, donation of electron from a filled metal d orbital into a vacant antibonding pi orbital of CO. Is that clear, guys? Is that clear? Yes. Because of that, what happens? Because of that, what happens, guys? Okay, okay, beta. Is that clear now? Yeah. So because of that, guys, no doubt in case of carbonyl, you can see if it is a single carbonyl, if you talk about, if it is single, the bond order between carbon and oxygen is 3. I'm repeating, the bond order between carbon and oxygen in CO, it is 3. And the bond length is, yes, guys, the bond length is 1.128 angstrom. Yes, it is 1.128 angstrom. All those who are watching, if you have not liked the video so far, do like the video. Do share the video. But guys, due to the formation of the pi bond, you can say it is more, attracted. The CO is more attracted towards the metal one. Therefore, the bond order gets decreased over here, or you can say the bond length increases. So, in this case, CO bond length, yes, I'm writing one thing, very important thing, guys. CO bond length, yes, in the complex, I'm repeating, CO bond length in the complex, guys, is more than CO bond length in CO. Is that clear? Is that clear, guys? Because question have been asked. Very soon I'll be teaching Grignard reagent as well, guys. Don't worry. Okay, Karthik, is that clear? Now let's have a look here. Let's have a look here, guys. In CO, the bond length in CO is this. Just now we had seen the bond length is 112.8 angstrom. Yeah, yes, but have a look at the screen. What is the bond length of CO in this, guys? No doubt, in this case, due to the bond between, yes, guys, you can see previously just now we had seen what there is a pi bond from metal to ligand. There is a sigma bond from ligand to metal. Guys, this type of bonding is called as synergic bond. I'm repeating. This is called as synergic. There is a mutual bonding. Therefore, it is called as synergic bond. Okay, guys, it is clear. It is clear. Now, guys, have a look here at this question. It is very, very clear that in this case, the CO bond length has to be more than the CO bond length in CO only. So out of the four, it is only this one which is more than 112.8 angstrom. Okay, so the correct answer is this. It is very, very simple. You need not to mug up the value. Okay, guys. But a metallic bonding is already taught by me. It is already taught by me in ionization energy. Do watch my video on periodic table of the topic ionization energy. Is that clear, Karthik? Is that clear, Karthik? Okay, guys. Thank you for watching. If you have not liked the video so far, do like the video. All those who have watched the video, who are watching the video, have not liked the video, do like it. Do share the video to all your friends who are preparing for NEET 2021, 2022, or in class 11, 12, or drop a student. Share to them those who are preparing for simply pre-board or half yearly examination or preparing for JEE Mains or advanced too. Guys, thank you for watching. Do like the video, do share the video, and do subscribe the channel. Let's crack NEET UG in English if you have not done so. Do press the bell icon too if you have not done so, and do apply this referral code of mine S18 in order to take the subscription and not only get 10% discount, but you will be getting some extra benefit as well, which you'll come to know once you apply the referral code of mine. Thank you for watching, guys. All the very best for your examination.